Okay, so this is the last video that you'll see from me for this semester. It's not an official lesson, but it is a video for the Unit 9 review. So this like officially marks the end. Okay, hopefully if you're watching this video, you've at least attempted to work the review yourself. You're not just watching this for free answers. You've tried working it yourself and you're stuck. That's what I'm here for. I'm here to help. Without further ado, let's jump into it. So the first four are just pure computation. Can you type these in the calculator? Can you compute them and get your answer? Now, 7 factorial. Let's first remember what factorial means. That means you're essentially counting down as you multiply. So 7 times 6 times 5 times 4 times 3 times 2 times 1. You multiply all those together as you count down. Now, you can certainly do that in your calculator. 7 times 6 times 5 times 4 and so on. Or you can say 7 and then do menu 5 for probability, 1 for factorial. 7 factorial. That gives you 5,040. So that would be your answer here. 5,040. Number 2, 9 factorial. Let's just do this within the calculator. Yes, it would be 9 times 8 times 7 and so on, but let's do it in the calculator. That's how I want you to really do it on the test. Just 9, and then go menu 5, 1 to get the exclamation point, hit enter. It's going to be 362,880. So 362,880. That's that one. Okay, the next one. There's 2 different ways you can do this. I'm going to actually break these up. I'm going to work 3 one way, 4 another way. But that's just so you can see each way. Number 3. This is 7 factorial divided by, well, what is 7 minus 3? It's in parentheses, so we can do it first. 7 minus 3 is 4 factorial. So once we get it to this step, we could type this straight in the calculator. 7 factorial. See if I can move this down where you can see it. There we go, just barely. So we can say 7 factorial divided by 4 factorial. And you get 210. That's easy enough. This is equal to 210. That's certainly one way to do this. The other way to do it is if we focus on number 4, this is the formula for a permutation. So 9p5, a permutation where you have 9 and you're picking 5 out. So in the calculator, that'd be NPR 9, 5. You could certainly do it this way as well. So let's do that. Let's remember how. We go to menu, probability, so 5, and then permutation is 2. And then we'll say 9, 5. Hit enter. 15,120. So that's two different ways you can work those. If you're like, well, I ain't gonna remember that the second way, fine, do the first way. You can type it in the calculator just like that and get your answer. That's okay with me. I just want to give you all your cards and you can decide how you want to play them. At least I dealt them all to you. Number 5. Kiera works at a restaurant where she must wear a white blouse, black pants, and black shoes. She has 8 blouses, 5 pants, and 3 pairs of shoes. Find the total number of possible outcomes. This is that one where, if you remember, like where we were making a sandwich almost. You just simply take what they give you. So the 8, the 5, and the 3, and you multiply them together. This is because of the fundamental counting principle. So 8 times 5 times 3. Let's do that right quick. 8 times 5 times 3. 120. So there's 120 outcomes. Boom. That's all you had to do on that one. Number 6 is just like it. Jemiah is preparing for homecoming and must decide what outfit to wear. Assume one of each must be chosen. Find the number of outcomes. Well, we just go down the table and multiply. 15 times 5 times 3 times 6 times 2. 15 times 5 times 3 times 6 times 2. 2,700. So you just, like I said, you just go down the table and multiply, and you'll get 2,700 outfits. Or outcomes, or however you want to say it. Outfits, outcomes. It's 2,700 of them, however you say it. Okay, number 7. Consider the list of numbers. 1, 2, 3, 4, 5, 6, and 7. So this is the list we're dealing with. How many unique 3-digit numbers can be made from this list? We're doing 3 digits. So 1, 2, 3. Now, it doesn't give us any conditions, so we can assume that they all of them can be repeated. So how many options do I have to choose from for my first one? 7 options. 1, 2, 3, 4, 5, 6, or 7. How many options for the second? 7. How many for the third? 7. So multiply 7 times 7 times 7 together, and you'll get 343 numbers. Okay, number 8. Actually a little, it's not a huge typo, but it's something that I want to fix. There we go. Okay, so again, we have the list of numbers 1, 2, 3, 4, 5, 6, and 7. How many unique 3-digit numbers can be made from this list of numbers where we cannot repeat a digit? So notice, we cannot repeat a digit. Still dealing though with 3 digits and the same number of options. Still dealing with that. So let's do 3 blanks here. 1, 2, 3. Now, how many options do I have to choose from for the first blank? 7. I have all 7 to pick from. Let's say I choose a 4. I cannot reuse the 4. So how many options are left? 6 options are left. Okay, let's say I pick I don't know, let's say I pick a 7. I can't reuse it. So how many are left? 5. There's 5 options left. Multiply these together. 7 times 6 times 5. That'll get you 210 numbers. Okay. So there's the first 8 problems. Number 9. How many arrangements of the letters in the states Florida and Mississippi exist? Which state has the most rearrangements? Well, we've got to break this up into our 2 states. Let's first focus on Florida. Florida. Now look at Florida. One thing we need to look for is repeats. Does Florida have any repeats? No. Okay, we don't have any repeats. How many ways, or how many letters, I should say, does it have? Florida has 1, 2, 3, 4, 5, 6, 7 letters. So the number of ways would be 7 factorial, which conveniently enough, we did that up here already. 7 factorial, because I'm lazy and don't want to type it in again. 7 factorial, 5,040. So that's how many ways Florida has, 5,040 ways. Now it says how much for each of them. So this is one answer right here. This is our answer for Florida. That's our answer for Florida. Now, we've done that one. Let's turn our attention to Mississippi. M-I, crooked leather, I, crooked leather, I, humpback, I. Mississippi. Okay. So let's see, do I have any repeats? That's the first thing I want to look for. Well, I've got 4 I's. So 4 I's, 4 S's, and 2 P's. Okay. How many overall letters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 11 total letters. So the number of ways would be 11 factorial divided by 4 factorial times 4 factorial times 2 factorial. Okay, let's type this monster in the calculator. So 11 factorial divided by, I'm going to have to open the parentheses, 4 factorial times 4 factorial times 2 factorial, and enter. Notice it looks just like it does on my paper, which tells me I entered it correctly. So 34,650 ways. There's that one. So this is our answer for Mississippi. MISSI Okay, so which one has more? Which one is more, 34,000 or 5,000? Definitely the 34,000. So our final answer is Mississippi has the most. Rearrangements. So there's, like I said, there's 3 parts to this answer. We had to get Florida's, we had to get Mississippi's, and then we had to say who had the most. And we did that. Because we're good like that. There's number 9. Number 10. Student council members have selected 15 students to choose from to fill the positions of president, vice president, secretary, and treasurer. How many? Well, first it says each student can only fill 1 position. So I'm going to highlight that. I'm going to highlight how many positions they're going for and the fact that we're picking from 15. How many outcomes are possible? So let's note some things here. First, note that order matters because president, vice president, secretary, and treasurer, those are all different. So order matters. Then that second part where it says each student can only fill 1 position, that means we're doing it without replacement. So order matters and we're doing it without replacement. What does that make this? That makes this a permutation. So let's see. How many are we picking from? We're picking from 15. How many are we actually picking? Well, we've got 1, 2, 3, 4. So we're picking 4. So since this is permutation, we'll say NPR of 15, 4. And we'll want to do this in the calculator. So menu 5, 2 for permutation. Do 15, 4. And we'll get how many ways? So there's 32,760 outcomes. 32,760 outcomes. Okay, there's that one. Number 11. There's 20 students in a high school geometry class. So I'm going to just kind of highlight that. That may be important. So let's highlight it. The students are tasked to form a group of 5 representatives. How many groups can be formed? Well, let's see. Does order matter here? Order does not matter. And can you pick a student twice if you want 5 in the group? No. We're doing this without replacement. So if order does not matter, what does that make this? It makes it a combination. Okay, so how many are we picking from? 20. How many are we actually picking? 5. So we want to do a combination. NCR 20, 5. I'm just moving this all over the place. So NCR, that's menu, 5 for probability, 3 for combination. So menu 5, 3. We're going to do 20, 5. It's going to be 15,504. 15,504 groups. Okay, so there's the front of the review. The first 11 questions are done. Now let's look at number 12. How many lines are determined by 9 randomly selected points where no 3 of which are collinear? Okay, so we're doing 9 points. No 3 can be collinear, which remember that means on the same line. Okay, well, remember something here. We've talked, this is like the 3rd time we've seen this problem or one like it. Every time I've said that 2 points make a line. 2 points make a line. So if I pick, let's say I have a point here and a point here. Does it matter whether I go this way or that way first? Does it matter? No, it doesn't. So we can say that order does not matter. Order does not matter. Okay, again, focusing on 2 points here. If I pick this point, can I pick it again in order to get a line? No, I won't go anywhere. So once I pick a point, I can't pick it again. That means I'm doing this without replacement. Okay, so order does not matter. It's without replacement. This is a combination. Well, since it's a combination, I need to get n. That's how many we have to pick from. Well, it says there's 9. So we're going to pick from 9. And then how many are we picking? We're picking 2 because we need to make a line between them. So this is going to be NCR 9, 2. So menu 5, 3. We're going to do 9, 2. It's going to give us 36. So that's how many lines we can make. 36 lines. Okay, there's 12. So for 13, 14, 15, and 16, we need to use this information that they give us about this bag of chips. So first I ask how many unique permutations are possible using all 14 chips. That's how many ordered arrangements are possible. How many ways can we order them? Well, keep in mind, these red, it's not like they're numbered 1 through 6. They're just red. I can't tell which one is red number 1 and red number 2. It's just all red. So that means each of these are repeats. If we're looking at unique arrangements, we have to deal with repeats here. So we've got 6 that are red. We've got 4 that are white. And we have 4 that are blue. Total, we have 14. So to figure out how many arrangements, we do 14 factorial divided by 6 factorial times 4 factorial times 4 factorial. Calculate that, and that's what gets you your answer. So let's see if I can maneuver this to see it. There we go. So 14 factorial divided by parentheses 6 factorial times 4 factorial times 4 factorial. Hit enter. 210, 210. So 210,000, 210. 210,000, 210 arrangements. That's how many we can make with all 14 chips. Okay, now we're dealing with probability. What's the probability of drawing a white chip out of the bag? So remember, probability is simply what we want over the total. So we want the number of white chips. So this is, I'm gonna write it out in words over total. Well, how many white are there? That's what, how do I know white? Because that's what they ask, white. How many white are there? There's 4 white. How many total? A bag contains 14 chips. So 4 over 14. If I do this in the calculator, 4 divided by 14, they tell me it reduces to 2 over 7. 2 over 7. You're more than welcome to stop here, But if this were a multiple choice question on the test, you would need to know that 2 over 7 is the same as, well, let's see, 0.2857. So the decimal to that would be 0.2857 or 28.57%. You would have to know how to do it all three ways. Put your answer in all three. So I'm just preparing you for that. Okay, 15. What's the probability of getting a red or white chip out of the bag? So the probability is going to be red plus white over total. So how many red do we have? There are 6 red. So 6 plus 4 over 14. It's going to be 10 over 14, which if we, again, using our calculator, 10 divided by 14 is 5 over 7. This is 5 over 7. Again, you're more than welcome to leave it like this, but know that 5 over 7 is, well, let's see, Control Enter, 0.7143, which is also 71.43%. You have to know all three ways, ultimately. Now, we're still not through with this information. The last one asks us, what's the probability of getting a green chip out of the bag? So we want the probability of green over the total. Now, do I have any green? I've got red, white, and blue. So no green over 14. 0 over 14 is just 0. 0 is your answer. It can't happen. That's impossible because we only have red, white, and blue. So impossible. Ain't happening. Okay, I need to change some numbers here, evidently. I forgot to change them. So we're going to use this next picture for 17, 18, and 19. Okay, so on 17, 18, and 19, a point is chosen randomly on segment AD. We're choosing a point randomly on segment AD. So well, first, what is the total length of AD? So AD, you add up 1 plus 3 plus 6, that whole thing is 10. So this is our whole amount. That's the whole shebang. They want us to pick a point on BC for number 17. BC, there we go. So the probability would be 3 over 10. BC over the total, 3 over 10. That's all there is to it. BC is 3, the whole thing is 10, so 3 over 10. Again, note that you can put this as 0.3, or you could also say this is 30%. So, okay, next one. what's the probability of picking a point not on AC? So we can't have that one. We can't have that one. The only thing we're allowed to have is CD. It's the only thing we're allowed to have. So that probability is 6/10, which reduces to 3/5. Three over 5. Again, as far as answer goes, that can be your answer, but you need to also be prepared to do a decimal or a percent. Okay. So let me erase this. We're through with that one. 19. What's the probability of picking a point on AB, or CD? Those are the two we're dealing with, AB or CD. So that's going to be the probability. Well, it's going to be 1 plus 6/10, which would be 7/10. As a decimal, we could say that's 0.7. As a percent, that's 70%. Okay, so there's 17, 18, and 19. Now for the last two. So yeah, last two. Now we're using a spinner. Use the spinner to find the probability of the pointer. 20 says landing on blue or green. So here's blue. And then here's green. First, though, what's the total? What's the whole shebang on the spinner? The whole is 360. The whole thing is 360 degrees. So probability of blue or green, that means the probability is equal to blue plus green divided by 360. Because that's the whole thing. Well, blue is 90 plus 45 divided by 360. 90 plus 45, 135 over 360. Now let's see what the calculator says that reduces to. 135, no, delete. 135 divided by 360. 3/8, which is 0.375. So 3/8 is our fraction, which we certainly could stop there, or we could say that's 0.375, which is 37.5%. Okay, 21, not landing on red. So I do not want red. Red is bad juju. No red. So that probability, you add everything up but the red. So 45 plus 90 plus 60 plus 45 over 360. If you add all these up, you should get to 40 over 360, which I can tell you right now, this will reduce to 2/3. If you don't believe me, try it on the calculator. 2/3. Now, as a decimal, it's going to be 0.6667, which is 66.67%. Okay, so with that, we have officially reached the end. This is the last video you'll hear from me. The next time you'll see me is if by chance you're taking the final via Zoom. Hopefully not. Hopefully you're in person. But that's it. We have reached the end of this insane semester. So congratulations. You have officially made it. With that, study the review, know it, ask me questions if you need to, and good luck on your test.